Hey everyone, today we are going to find how to find derivatives using two methods, one called the product rule, one called the quotient rule. Usually I do each of these in separate classes, but with the format of this year, we're going to do both in one, but they're very similar. So these are two tools that we use to find derivatives quickly when certain conditions are met. So first, I'm going to talk about the product rule. So the product rule. What is it and when do we use it and what is it used for? Product rule is used to find derivatives. So we use it to find derivatives when you have the product of two functions. So when you have a function, that is the product of two functions. Is the product or multiplication of two or more functions. Okay. So an example would be like if I gave you this function, ready? If I said find the derivative of this function, x sine x. This is a product of two functions. You have this one, function 1, and you have the sine x, that's function 2. This is a product. You have to do a very specific procedure to find the derivative of this. Okay, so I'm going to show you the general formula and then we'll practice a few examples. All right, so the general formula, it looks like this. It says that, all right, if you have a function, we'll call it y equals f of x times g of x. So you have this y function that is the product of two functions. The derivative of this is equal to the derivative of the first function times the original second plus the derivative of the second function times the original first. That's the product rule. We will go through lots of examples on how this works. Got to memorize it. Derivative of the first times the second plus derivative of the second times the first. So let's do an example right over here of the one we just did. So I already showed you what the first function was. It was just x, and the second function was sine x. So here's how I like to do it. I typically like this little shorthand when we're learning. Identify the first function, it's x. Identify the second function, it was sine x. This is different from what we were doing before because look, it's not a coefficient in front anymore. It's an actual function in front. You can't just carry that to the end. You have to find the derivative of it. So the next part says find the derivative of this first function. Well, the derivative of x using the power rule is just 1. And then the derivative of sine x using your derivative rule sheet is cosine x. These are the 4 things you need. You put them together based on what the power rule or the product rule says to find the derivative. So it says that's the derivative of the first times the second. These two go together. So 1 times sine x plus the derivative of the second times the first. So cosine x times x, or x cosine x. And that is the derivative function. Sine x plus x cosine x. It's a pretty bizarre looking derivative, but that's how this is going to start to get. We're going to get these kind of funky looking derivatives based on these funky original functions we're starting with. And as always, check. So real quick, let's remember how to check. I give you this function that was x sine x. I say find the derivative of that, and then I check my answer. And how did we do? Yeah, same function. So the derivative matched up with the original. Or the derivative matched up with what I calculated the derivative to be. Yeah. Okay, so let's do some more practice ones. Some other common ones are I'll do two more. I think that'll be enough. If I have this function, ready? Root x minus 3x times natural log of x. Okay. No. This is a product rule. How do you know it's a product rule? Well, you have one function times another function. So I like to identify the two functions. The first function is all enclosed in parentheses here. It's root x minus 3 times x. The second function is natural log x. So let's find the derivatives. The derivative of this first one is a lot of power rule. So I'm going to go through it a little bit quicker. Change it to the x to the 1/2, and then you just multiply in front, and you end up getting 1/2 x to the negative 1/2 minus 3. The second one derivative is the derivative of natural log x, which looking at your derivative rule sheet is 1 over x. And then the product rule says put them together. Derivative of the first times the second. So the derivative would be the derivative of the first times the original second plus the derivative of the second times the original first. And yeah, you could probably clean this one up a little bit, but for now, I don't really care about that. I just want to make sure you're putting things in the right spots. Okay. So that's kind of what we are all about. Let's do one more. This time, let's say I have this function g of x is equal to, let's do a trig one, yeah. So let's do cotangent, let's do 4 cotangent x sine x. All right, so two functions here. Oh, this one we have an actual coefficient on this one, but that's fine. You can still call this f1, and we can call this one f2, and we can go through and do the product rule. One function times another function, so we have to use the product rule. f1 is 4 cotangent x. f2 is sine x. So the derivative of the first one, carry the 4. Derivative of cotangent x is negative cosecant squared x. If you look at your derivative rule sheet. That's one that's a little bit more obscure, but we got to start memorizing these. The derivative of sine x is a little bit easier, cosine x. And then put them all together. Derivative of the first times the second, which is, so let's see the bottom one, negative 4 cosecant. Notice these are multiplication, because it doesn't really matter the order you put them. Plus these two put together, 4 cotangent x cosine x. And that's fine. Definitely some simplifying you could do there, but that'll work for me. All right, so that's the product rule. You basically just have to remember the pattern. Derivative of the first times the second plus derivative of the second times the first. And don't take shortcuts. The common error I always see is people just taking derivatives one by one. But you can't do that. You got to remember this setup. I'm recording right now. I'm recording. So you have to go through it and make sure you're following the entire process. All right, so let's do the other side of this called the quotient rule. Quotient rule. So quotient rule says this. If I have a function that is that's made up of the quotient of two functions, I would use this thing called the quotient rule, which is similar to the product rule. So it looks like this. If I have a function, we'll call it y, which is f of x divided by g of x. What does this derivative look like? Well, the derivative is, and it's on your derivative rule sheet, the low one times the derivative of the high one minus, unlike the product rule, which was a plus, the high one times the derivative of the low one all over the bottom one squared. Okay, that's the quotient rule. How am I supposed to remember this? Here's a little phrase to help you remember. low d high minus high d low. Low d high minus high d low. What do I mean? The low one times the derivative of the high one, minus the high one times the derivative of the low one, and then all over the bottom squared. So all over low squared, all over low squared. So just got to remember it. You got to do the practice. You got to be willing to go through it. You got to go back and look at this again if it's confusing, because it's just going to keep adding to all of these derivative rules that we got to kind of be mindful of. So let's try a couple practice. If I give you this function, which is 4x cubed over e to the x. This is a quotient rule because we have the quotient of two functions. We have a function in the numerator, a function in the denominator. So we can do the same logic that I was doing for the product rule. I identify the top function. It's 4x cubed. I identify the bottom function. It's e to the x. And then I find the derivative of each of these. The derivative of the bottom or top function looks like a little power rule, so 12x squared. Derivative of the second function is a derivative rule sheet. E to the x, its derivative is e to the x. So now we put them together using the formula. And it says low d high. So the low one times the derivative of the high one. Low d high. Low d high minus high d low. All over the bottom one squared. All over e to the x squared, which is the derivative. And I'll take that for now. You can definitely simplify this. Look, we have e to the x's in all of our terms, so we could reduce everything by an e to the x. We could do a lot of things, but that's fine for now. You can leave it just like that. Okay, and that is the crazy derivative function for this quotient function. Okay, so that's the point. We have to start getting good at finding derivatives of lots of different looking things. All right, let's do another one. What if I have the derivative, g to the x equals, let's do sine of x divided by cosine of x. Quotient rule. Low d high minus high d low is what we're going to have to do. But let's first identify the functions. F1 is the top one. F2 is the bottom one. Let's find the derivatives of each of these. Derivative of sine is cosine. Derivative of cosine is negative sine. And then you just got to remember the order. Low d high. So the low one, which is F2, times the derivative of the high one. So cosine times cosine. So the derivative is going to be cosine times cosine minus high d low. Sine x times negative sine x. All over the bottom one squared. And this is fine, but check it out. We can actually simplify this one a little bit more. And if we have two cosines, that's the same as cosine of x squared or cosine squared of x. Two negatives make a plus. And we have sine x times sine x, so sine squared of x, all over cosine squared x. Okay? So if you see this thing, depending on how much you remember from your trig days, there's an identity for this. It's the major Pythagorean identity that says sine squared plus cosine squared equals something. It's called the Pythagorean identity for trig. We don't do a lot of trig identities. We do the basic ones with secant, cosecant, cotangent. But this one's pretty important. Sine squared plus cosine squared is 1. if you look it up. Sine squared plus cosine squared is 1. It goes back to the unit circle, and if you have the x is cosine and the y is sine, if you square both of those, it equals the hypotenuse, which is 1. 1 squared is 1. So it's a pretty important identity. We're going to use it right here for a reason, because we can simplify this. 1 over cosine squared is literally just secant squared. So really, the answer to this whole problem was secant squared. Well, we almost could have known that right off the bat, because if you go back to this, sine over cosine, that's just tangent. And the derivative of tangent is on your derivative rule sheet. Derivative of tangent is secant squared. So this was kind of a proof for the derivative of tangent equaling secant squared using the quotient rule. This is pretty cool. I like things like this that show that, oh, the things we know how to do actually work out. Yeah. So product rule, quotient rule, your job is to recognize when to use which. I think that's good enough. Start the homework, because it's just a lot of practice. It's one of those things that it's going to take practice, knowing how to use the quotient rule, knowing how to use the product rule. Okay, so there's 2 of them, product rule and quotient rule. Same thing, pretty much just identify function 1 and function 2 and get them plugged into the right setups. Okay, and that's where I'm going to stop for now.